Hey guys, Mr. Yisley here. So we're on to lesson number 7 in chapter F, all about fractions. And lesson number 7 is all about how to add fractions. So in this first portion, we're going to talk about if the denominators are the same. So if they have the same number at the bottom of the fraction, how we add those types of fractions. And it's really relatively simple. Hopefully this is a review for you. So if the denominators are the same, if they are mixed numbers to begin with, let's make sure to convert them to improper fractions, right? That would be improper, can't spell right now, improper fractions, right? We always want to do that first. Then once we've done that, right, the next step is we're going to add the numerators. So whatever's at the top of your fraction, you're going to add. You're going to add those two numbers together, or 3, however many fractions you have. Right? Then we're going to keep the denominators the same. So we're not going to add those denominators. That denominator was the same in both fractions, and it's going to be the same number in our answer. All right? And then once we've done that, we need to check if we need to reduce that final fraction. So sometimes after we add them, we end up with an unsimplified fraction, and we need to reduce it using that method that we learned about before. All right, so let's take a look at our examples. We've got two examples here. Example A, 3 over 7 plus 2 over 7, or 3/7 plus 2/7. Well, I notice that, hey, these denominators are the same, so I know that my answer, my denominator, is going to be 7. All right, there's no improper or no mixed numbers, so don't have to worry about that. So my first step after that, or step 2, would be to add the numerators. So I'm going to add 3 plus 2. Well, 3 plus 2 is 5, and that is my new numerators. Step 3, keep the denominator the same, which I already wrote. And then we need to check, final step, if it needs to be reduced. So do 5 and 7 have a factor bigger than 1 in common? Well, they do not, because 5's only factors are 1 and 5 does not go into 7. So that makes 5/7 my final answer. So again, process, just add the numerators if the denominators are the same, and then bring the denominator down as it is. So try example B on your own. Again, don't forget that last step to check if we need to reduce the final fraction. All right, so do we have any mixed numbers in this? No, we don't, so don't have to worry about it. If we did, we'd want to convert them to improper fractions. So step 2, we're going to add these numerators. So 2 plus 3, well again, that is 5. All right, then I'm going to keep the denominators the same, so 5 over 10. Last step, check to see if we can reduce it. Well, I know that 5 and 10 have a common factor of 5 because they're both divisible by 5, so I'm going to divide by 5, divide by 5. So final answer here, 5 divided by 5 is 1, and 10 divided by 5 is 2. So final answer is 1/2, or 1 over 2. So that's how we add fractions if the denominators are the same. But if you flip your page over, we've got to talk about as well if the denominators are different. How do we add those fractions? Well, step 1 of that, all right, is still the same. If they're mixed numbers, we've got to convert them to improper fractions. All right, we won't always want to be doing it with improper fractions, otherwise we can mix numbers up and get a little confusing, so improper fractions are always going to be the simplest way to figure that out. All right, step 2 is we want to find the largest common denominator, all right? The largest common denominator, or excuse me, not largest. I don't know why I said that. Least common denominator. We definitely don't want the largest. We want the least, which just simply means we're looking for the smallest number that they'll both evenly get to. We can multiply to, or they can divide evenly into. And you may see it referred to as LCD, or even lowest common denominator. I apologize, not largest, least common denominator, or lowest common denominator. So again, these are factors we're looking at. A quick just note about that is when you're looking at the numbers, all right, always check to see if the largest number, all right, so whatever the factors are, let's say it was 9 and 18 were the two denominators. Check to see if that small number of 9 goes evenly into 18. If it does, that means we only need to change one of the fractions, right? So big things we're looking for is, again, what is the smallest number that both denominators can multiply to? So what is the smallest number that both denominators can multiply to? That's what we're talking about with least common denominator. And then, as I just said earlier, check first to see if the smaller denominator, right, the smaller denominator goes evenly into the bigger denominator. Because if it does, we only have to change one of the fractions. Right? Once we figured out what that least common denominator is, we are then going to multiply the top and bottom of the fraction. So the fraction that we're changing, or if we're changing both fractions, you're going to have to do it separately on each one. We're going to multiply the top and bottom of the fraction by the same number. So it has to be done by the same number. Right? I can't multiply the top by 2 and the bottom by 3. Right? If I'm multiplying the bottom by 3, that means I have to multiply the top by 3 as well. And then again, you must do this to each fraction individually. So if I'm multiplying one of my two fractions by the number 3 on the top and bottom, I shouldn't be multiplying the second fraction by that same number, because that would mean they already had the same denominator. So what you multiply each fraction by is going to be different based on what number you're trying to get to. And I know it kind of sound confusing as we're talking about it. It'll seem much simpler when we look at it. Fourth step, we're going to then add the numerators. So once we've converted these fractions to common denominators, then we're back into what we just learned about previously. We're going to add the numerators, keep the denominator the same, that least common denominator that we learned about, and then last step, check if we need to reduce the final fraction. So do we need to reduce it or simplify it? All right, I know that was a lot of talking. It kind of sounds a little confusing. Let's look at it in live action. So example A, 4 over 15 or 4 15ths plus 5 over 9 or 5 ninths. So first thing I notice, all right, we're adding. So do I have any mixed numbers? Nope, no mixed numbers, so I don't need to convert them to improper fractions. I do notice that the two denominators here, 15 and 9, are different. All right, so at this point I know I cannot add them until I have a common denominator for both, and we're looking for the least common denominator. So again, the smallest number that both can multiply to. Well, first I want to check to see if the smaller denominator goes evenly into the bigger one. So does 9 go evenly into 15? No, it doesn't. Right, so that's an indication to me that I have to change both of these fractions. So once we know that, hey, it does not go evenly into both, I'm going to have to change both of these fractions. So now I'm looking for what's the smallest number that both 9 and 15 go into. So I think the easiest way is just to kind of write out the multiples of each one of those. So I'm going to write out the multiples of 9 first to begin with. So 9, 18, 27, 36, 45, 54. I'm just going to list out those 6 right there. Then I'm going to list out the multiples of 15 and see, is there any number, do I hit any numbers that I already have on that 9 list? Well, first one would be 15, then 30, then 45. Oh, right there, 45. That's on both lists, right? It's on both lists. So that means that my denominator of both of these is going to become 45. So I'm going to go ahead and write that because I know that it's going to get there. All right. Well, now my next step is I've got to figure out what did I multiply 15 by to get to 45. Well, if I've got the multiples, I just count them. 1, 2, 3. So I multiplied 15 by 3, right? Well, that means I also have to multiply the numerator of this fraction by 3. So 3 times 4 is 12. And now what we've created is what's called an equivalent fraction, right? 12 over 45 is the same fraction as 4 over 15. It's just written in a different way. Right, well, now I've got to do the same for my other fraction. What did I multiply 9 by to get to 45? Well, you may know that, or you can count your multiples. 1, 2, 3, 4, 5. So I multiplied it by 5 to get there, which means I now have to multiply the top by 5. So 5 times 5 is 25. So now I've created two fractions that have the same denominator. And as we learned about before, now we can add these fractions. So I'm first going to add the numerators. So 12 plus 25, that is 37. And then I get to, as it says in step 5, keep the denominator the same, which is 45. And then last step, I need to check, can these be reduced? Well, I believe we learned about earlier in the chapter that 37 was a prime number, which means it's only divisible by 1 in itself, which means that there is no common factors between these two, so this is as simple as this fraction gets. So much easier when we see it in action than when we're explaining it just through words. But the process is the same. So if you've got those notes up above, you've got what you need in order to work all problems of addition that have different denominators. All right, so let's take a look at example B. If you want to try it on your own, go ahead and pause it and then check your work with mine. So first step, if they are mixed numbers, convert them to improper fractions. Well, both of these are mixed numbers, so I'm going to go ahead and I'm going to convert them to improper fractions. Well, my steps for that was first multiply the denominator times the whole number, so 2 times 3 is 6. Then add that to the numerator, which is 7. So 7, and then the denominator stays the same at this moment. So 7 over 2. Then I'm going to do it for the second one. So 4, the denominator times the whole number is 2, which is 8. Then I'm going to add that to the numerator. 8 plus 3 is 11. And now the denominators stay the same, so 11 over 4. All right, so step 1, I've got them into improper fractions. All right, step 2, find the least common denominator. So we're looking for the smallest number they both go into. A good thing to check first is to see if the smaller denominator goes evenly into the bigger denominator. So does 2 go evenly into 4? Yes, it does. So that's an indication to me that I only need to change this first fraction. The second one gets to stay the exact same. Right? So what do I need to multiply 2 by to get to 4? Well, that's 2 times 2, which means that I also have to multiply the numerator of this fraction by 2. So the second fraction here is going to stay the same, so I'm adding 11 over 4. Now the first fraction becomes 2 times 2 is 4, that's my new denominator, and now my denominators are the same. And then 2 times 7 is 14. So now that I've got the same denominators, I can go into adding my fractions. So my process is to add the numerators, so 14 plus 11 is 25, and then denominator stays the same. And then last thing we're checking for is, can we reduce the final fraction? Well, does 25 and 4 have a common factor other than 1? Well, no, they don't, because 4 is an even number, and the only other factor of it other than 1 and 4 is 2, and 2 does not go evenly into 25. Now, you may be saying, well, don't I want it as a mixed number for my answer? No, you don't have to. You can leave it as an improper fraction. All right, but if you wanted to convert it into a mixed number, that's completely fine as well. So we could go through our process, but again, we're adding another step if we do that, right, of figuring out the mixed number. So first things first, put it into my house. Denominator goes denominator goes on the outside. Numerator goes on the inside, and then we divide it out. So 4 does not go into 2, but it does go into 25 6 times. 6 times 4 is 24. So 25 minus 24 is 1. Got to add that decimal in now. Oops, excuse me, that's not what we're doing. That's finding it in decimal form. We're not wanting to do that. So what we would do is we would divide that in, and we'd see that it goes in 6 times. And then what's remaining? 1, and then our denominator 4. I've got too much going on, I apologize that. So this would be the same, so we'd either end up with 25 fourths or 6 1/4. It is still adding an extra step, but again, remember, it doesn't have to go evenly when we're converting to a mixed number. The remaining becomes our numerator, and the denominator would stay the same. My encouragement to you is don't add an extra step onto yourself. Just leave it as the improper fraction and go with 25 over 4. but definitely do not turn it into a decimal unless it asks you to. So your answer should either be an improper fraction or our mixed number. All right, well that should be enough for you to continue on in your notes. If you have any additional questions, please let me know.